In this video, we're going to take a look at what we saw in our previous video and how it can be applied to various applications. So 1.5 today, we're talking about applying linear equations to the real world. And basically what we're going to be seeing is the same equation that we've become very familiar with, that y equals mx plus b. And we're going to be not using words like slope and y-intercept, though. We're going to be looking at the variable rate, or the rate things are changing, is what's going to tell us our slope. The other thing we need to find is the fixed cost, or the starting value in the problem, and that's going to be our b, or the y-intercept. So we're just going to take a look at a couple examples today and see if we can identify the variable rate, the fixed and starting rate, and use that to make predictions, conclusions, and whatnot. So starting out with our first example, let's say there is a taxi that charges 45 cents per mile, so $0.45, plus a $6 flat fee. I want to know what is the cost of 15 miles. A couple things we need to identify from this equation is, can we tell what the y-intercept is, the starting value? Can we tell what the variable rate is, the slope? Well, the starting value of this taxi trip is the $6 flat fee. That's going to be our B. $6 is what the cost starts at. The variable cost, the changing cost, is this other number. It's 45 cents per mile. So that's going to be our M, our slope. So if we want to make an equation to represent this taxi, we would say y is equal to the slope, the 0.45, times the number of miles, because it's per mile. I'm going to use M for mile, not to be confused with slope, plus B, the starting value, the starting cost of this taxi cab, was that $6 flat fee. So if I'm interested in what's it going to cost to go 15 miles, that's what I'm going to plug into for my variable, in this case M, my miles. So y is equal to 0.45 times 15 plus 6. And that's something you can easily calculate on any calculator. 0.45 times 15 plus 6 comes out to be 12.75. So this taxi bill is going to be $12.75. Let's try another example. How about we look at the variable cost to produce a product is $12. We have a $12 variable cost. What that means is every product we produce is going to cost us $12. There's also a fixed cost And the fixed cost for all the machinery to make this product is $1,150. $1,150. We are going to write the cost function. Scroll that up to give us some space to work on it. So, we need to identify the slope and the y-intercept. One thing about the slope is what's changing. So you might think about that as our variable cost. Variable cost, that's the changing amount. That is my slope per product. The 1050, that's fixed. That's not changing. That's what's going to be added to the end. The starting cost, no matter how many I produce, is 1150. So that's going to be my B. So this cost function is going to be y equals my slope, $12 per item. And I'm going to say, since we're talking about products, I'm going to use P for products. 12 times the number of products plus the y-intercept plus the starting amount, the fixed cost of 1150. This equation then could be considered my cost function. It's going to tell us how much it will cost to produce however many products we're producing for the day. Let's try another example. Let's say it costs $850 to manufacture, if I can spell manufacture, $35 items. And it cost $900 to manufacture 40 items. I want to know how much will it cost to produce 90 items. Here we're not told what the starting fixed costs are to manufacture these items. We're also not told what the variable cost is or the rate is per item to produce. What we're given is information about each situation. So what we need to do is we're going to list these out as points. We can use the points then to find the slope, and the slope to find the y-intercept, and then we will have an equation. To help guide me as I find my points, I make sure I label clearly what I'm using for x and what I'm using for y. What I use for x, I want that to be the thing that answers my question. How much will it cost to produce 90 items? That's going to be our x, the number of items. I'm going to use n. That's the thing that's used to find the answer, which is the cost. Notice the first variable is what is used to find the second variable, the cost. So if that's the order of my points, my first point has 35 items, $850. 35 is the number of items, and 850 is the cost. I also have 40 items being produced at $900. So 40 is the number of items. 900 is the cost. That's how I'm going to get my 2 points. Now that we have 2 points, this can solve just like the problems that we saw in the previous lecture. we can find our slope, which should be in blue. The slope is y2 minus y1 over x2 minus x1. And we have an xy from our first point and second point. So y2 is 900 minus y1 is 850 over x2, which is 40, minus x1, which is 35. 900 minus 850 is 50. 45 minus 35 is 5. And so we end up with 10. 10 is our slope. So now we can go to our y equals mx plus b equation to find out what the b is going to be. We can use either point as we do this. Let's just use the first point for no particular reason. So the y there is 850 equals m, my slope, 10, times x, which is 35, plus b, and that's what we're looking for. So if we multiply, we have 850 equals 350 plus b. Subtract the 350 from both sides. And what we're going to end up with is 500 equals b. Now we can make our equation. Our y equals m, the slope is 10, times the number of items plus the starting value of 500. And then we can answer the question about the 90 items we're producing. That's the number of items, so it gets plugged in for n. So we have y equals 10 times 90 plus 500. We can do that on a calculator or maybe in our heads. That's 1,400 is the cost for 90 items. Let's do another example. Very similar to this one. Number 4. This is an interesting problem to look at. Water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. It boils at 100 degrees Celsius or 212 degrees Fahrenheit. What we're going to attempt to do is to find an equation to convert Celsius, degrees Celsius, to degrees Fahrenheit. And we're going to use it to find when both Celsius and Fahrenheit are the same. So again, we're going to have to find a couple points because we don't know the slope, the rate of change, the variable temperature. We don't know the starting value. We don't know the y-intercept, so we just have points. And first, to guide our points, what are we going to use for the first coordinate and the second coordinate? Remember, the first coordinate wants to be what I start with. The second coordinate, we want that to be our answer. Our goal is to convert Celsius to Fahrenheit. We're going to start with Celsius, and we're going to go to Fahrenheit. So that's the way we're going to set up our points. So in our first situation, water freezes at 0 Celsius or 32 degrees Fahrenheit. Water then also boils at 100 degrees Celsius or 212 degrees Fahrenheit. Now we walk through the same steps we just did. We're going to find the slope, And then we'll find the y-intercept. We've got an xy, an x and a y, a first point and a second point. So y2 is 212, minus y1 is 32, over x2, which is 100, minus x1, which is 0. Subtracting 212 minus 32, we'll get 180. Over 100 minus 0 is 100. Reduce that, we get 9/5. Now we can find the y-intercept. We can pick either point to find the y-intercept. This process we should be really good at by now. I really like using the first point because it's got the number 0 in it. So to find our y-intercept, y equals the slope 9/5 times x, which is 0, plus, whoops, let me back up actually. We don't actually need to find the y-intercept, do we? What's interesting about this point, this first point to us, is when we have 0 in the first coordinate, the next coordinate is your y-intercept. 0, 32 is just going to be up 32 on the y-axis. 32 is the y-intercept. And we could have found it by plugging the values in. We would have gotten the same answer, but this was much quicker. So we're ready to come up with an equation. Y, which I'm going to use F so I know what we're talking about, Fahrenheit, is equal to 9/5 times x, which represents the Celsius. Actually, I'll put that 9/5 in blue, so we know that's our slope. Plus b, the y-intercept is 32. This is the equation we can use to convert convert Celsius to Fahrenheit. The question wants to know is, when are they the same? So what I'm going to do is I'm going to use the same variable for both of them to see what that same value is equal to. So we're going to say F and C are equal to each other, and we're going to use the letter A to represent that value. So A equals 9/5 A plus 32. Going to get rid of that fraction by multiplying everything by 5. Remember, when we do that, we have to multiply each term by 5 on both sides. The 5's reduce, so we have 5A equals 9A plus 5 times 32. What is that? On the calculator, 160. Giving me a little more space to work. We'll subtract the 9A from both sides. Oops, not divide. Subtract the 9A from both sides, so we get negative 4A equals 160. And finally divide by negative 4. And we find out that both Celsius and Fahrenheit are the same when A is equal to negative 40 degrees. At negative 40 degrees Fahrenheit, negative 40 degrees Celsius, we have the same temperature in both situations. Cold. That's what it is. Cold. I want to do one more example here in this video. We're going to call it example number 5. We're not really doing anything new in this video, so we can make a shorter video. What we're really doing is trying to take what we've seen before and apply it to some real-world situations. So we get a short video today as a result. I want you to have time to work on problems and practice, practice, practice. The population of Moses Lake in 1990 was approximately, according to Google, 12,000 people. In 2011, it was 21,000. What we want to do is predict the number in 2014. How many people are in Moses Lake in 2014? Assuming we have a linear relationship, which is a little bit of an assumption, but we're going to go with it for this example. Again, we're going to do much the same thing we've seen in the previous problems. We're going to clearly define what our x and y is going to represent, and then we will use that to come up with 2 points. And then we will use those points to find the slope and the y-intercept. For this problem, we're going to predict the number in 2014. 2014 is what I start with. I'm starting with the year, and I want to end up with the population. So x is going to be the year, y is going to be the population. And actually, we're going to simplify this problem a little bit on top of that. We could use the year 1990 as the x value and the year 2011 as an x value. The problem is those are really big numbers, and sometimes big numbers turn into small errors. And that's a problem. To make this a little bit easier to work with, what I want to do is we're going to make 1990 represent the year 0. And so then 1991 is year 1, 1992 is year 2, and then 2011 would be year, from 1990 to 2011 is 21 years. Year 21. Smaller numbers are going to be easier to work with. It's also going to make our y-intercept a lot easier to find. Let's take a look at it. So we've got year 0 with 12,000 people. Year 0 with 12,000 people. We've got year 21 with 21,000 people. Year 21 with 21,000 people. We can see really quick by just looking at this, since we've got 0 comma something, that something is our starting value for the population. Year 0 is where the situation started. That's the starting population of 12,000 people. We just need to find the y-intercept. Well, I'm sorry, we just need to find the slope. We have the y-intercept. The slope is y2 minus y1. So we've got an xy and xy. First point, second point. y2 is 21,000. Minus y1 is 12,000. Over x2, which is 21, minus x1, which is 0. That's going to give us 9,000 over 21. That's going to reduce. They're both divisible by 3. 3,000 over 7, and that's about it. I'm pretty sure we can't divide 3,000 by 7. So we can come up with our equation then. Y equals m. The slope, we're getting 3,000 over 7 people every year times the year. I'm going to use, let's see. Let's not use y equals. Let's use p equals, because y is the population. So we're going to use p instead, and we're going to use y for the year plus b, the y-intercept. The starting value was 12,000 people. And we're going to use this to make a prediction about the year 2014. Remember, we have to figure out how many years after 1990 that was. That's 24 years after 1990. So we're going to plug 24 into the y. So population is equal to 3,000 over 7 times 24 plus 12,000. And that's going to tell us what the population equals. So on our calculators, 3,000 over 7 times 24 plus the additional 12,000 people gives us approximately 22285.7 people. Since we're talking about people, somebody, maybe they're pregnant and they only have 0.7 of a person. We're not gonna go there. Let's just round this up. So let's say for our final answer, there are about 22,286 people in 2011. So that's kind of an introductory look at how we can apply these linear equations to the real world. We're going to see all types of different problems in the homework assignment tonight. What you really need to focus on finding is, can you figure out what is the variable rate, the rate of change, the slope, and what is the fixed value, the starting value for the problem. Once you have that, you can make an equation and answer the problems. Good luck on your homework, and I'll see you in class with questions.